So hey guys, so today we're gonna take a look at a really cool problems from Leetcode, which is to find the number of islands in a two-dimensional grid. So we are given with a two-dimensional grid with ones and zeros, and we're supposed to find the number of islands within the grid. So one in this grid represents the land, and zeros represents sea. So for example, here we have all these ones which are super close to each other, which is like one. So all these ones here will form an island, and all these ones grouped together are surrounded by zeros here. So essentially water. So we have one island in this grid, and so if we take a look at the second example, we have four ones here, which form an island. This one is not connected to this land here because these are like diagonally located one, so we don't count that. We just take into account all the ones at the top, the left, and the right, and the bottom. So this would be its own island. This one would be its own island. So we have two islands so far, and this third group of ones would be the third island here. So we have three islands in total in this two-dimensional grid. So the way that we're going to solve this is by making use. So we're going to go through, we're going to iterate through all the rows and columns of this grid. So we have a one here, and then once we have a one, once we find that we've like located a one, we're gonna call another method, and we're gonna check if all the adjacent elements of this one is one as well. So in this case, we find that this is a one, and then we call another method to see if the adjacents are one as well, and we will start replacing this ones with zeros, and then once we go into all this recursively, we'll check if um, the ones that are located at the top and the bottom of here is also one, and then we will again check if for this one if the element at the bottom is a one again. If it's not one, we'll just come back, we'll just return, we'll not do anything. But then if it is one, we'll just go recursively call it again and again. So that's how the problem works. And let's try to solve this problem in Java, right? So I'm just going to create an initial variable called count, and then this is what we'll be returning after we do the iteration. So I'm going to iterate through all the rows, then um, drop length, then I plus plus, and then for int j is equal to 0, then grid of I dot length j plus plus, and then so we need to check if the element at this, that is typo here, the element at this position is um, it's a land, right? So that's kind of the basic idea here. We need to check if if when iterating throughout the grid we found a land. If we did find a land, we'll have to increment the count variable. So I'm just gonna do count is equal to count plus one, and then call another method which is check BFS, because we're doing a breadth first search uh, for all the elements that are closer to the one. So I'm just gonna pass in the grid and the location that we found I, right? So found that, and then once we do all the iteration, I'm just gonna return count here. So the one thing that's still left out is to actually implement check BFS. So I'm gonna do that. Um, so the way that we do that is just I'll check BFS, and then we're getting a character two-dimensional grid array, right? So did that, and then we're getting I, and then we're getting J, right? So we're gonna check for a few conditions here. So we wanna check if the index I is indeed lesser. So the index I is a row, right? So it should be greater than, well, it's obviously gonna be greater than zero. So should be less than grid dot length, and or so we need to check for invalid conditions. So if it is greater than the grid loss length and if I is less than 0, that's an invalid condition, and we have another condition to check as well. We need to check for columns. So if j is maybe like greater than grid of I dot length, or if j is lesser than 0, and we need to also check for another condition to see if grid of I and j is equal to 0, right? So if we did find water, there's no point in actually checking the waters up, down, left, right. So we're just gonna, if it is just water, we are going to return. There's nothing that we could do. I'm just gonna format this nicely so that it's easier to read. Right, so did that, and then we're doing a return because there's nothing else we can do. But if it is a valid grid with one, and then if we're in the valid position, we should be checking all the above, left, right, and bottom positions. So what I'm gonna do is I'm gonna pass in the grid, and then I'm gonna do I plus one, and then j, and then we're gonna do this 4 more times, and then say I, and then j plus 1, and then j minus 1, I, trying to think if there's anything that I'm missing out. I minus 1, and then j, right? So this should pretty much be it. Yeah, let's try to run and see if it actually works. All right, so there was one thing that I missed out. Remember that I told you guys about changing the ones to zeros after we visited them, because we don't accidentally go back. So if we went through this one, and then we are going to these adjacent things, and then we are also checking from this one to the above one at the top. We don't want to do recursively, like we don't want to end up calling the same thing again and again. So we're setting this one to 0 after we're done with it, and then once we go here and then we check back here, it's 0, so we don't go back because we'll be checking every single element. So we need to set a condition to make sure that the previous grid is set to 0 before we iterate all the adjacent ones, right? So that's kind of the idea here. So I'm gonna run this one more time, and then I'm gonna submit it. All right, so that's pretty much it, guys. Fairly straightforward, and I will see you again tomorrow with another problem.